Yeah. Oh, yeah.
Uh, a very warm good evening. So, am I audible? Okay. Uh, so, a very warm good evening to you all. Uh, so, today we will be talking about the big two lecture sessions. So, these are our course outline and the reference material which we have. The course module. In the course module, we have first started with the interaction between economy and the environment, and then we try to understand the welfare implication of national income and sustainable development by defining the sustainable development base to measure it, and then we have learned the definition of environmental goodness curve, its implication, what are the limitations in the module 3. So we are here till the module 3 of the course. Uh, can you give me a thumbs up if I'm audible and my screen is visible? Am I audible? Please give me a thumbs up.
Yes, ma'am.
Okay, thank you so much. Okay, so we are at the about the half of the module 3, where the economic growth, environmental degradation, we have tried to understand through environmental goodness curves as well as the definition of sustainable development. So last in the last interactive session, we have tried to understand the module 1 and a part of module 2. So in module 1, we have seen the interaction between economy and the environment. So how does the economy and environment affect each other? What are the services of environment? And then how the optimal extraction of environmental services are needed so as to maintain the equilibrium and maintain the environment to avoid the extensive environmental degradation. So that is what we have tried to understand. Then we have asked the question that why there is environmental economics, where there's requirement of environmental economics when there is already the microeconomics which is available. So in this we have said that the price signal for natural uh, natural environments such as air quality, water quality, they do not have proper price signals. So therefore, there is a requirement of environmental economics beyond the uh, classical microeconomics concept. However, the various theories of environmental economics are derived from the classical economics theory. So, in the last lecture, we have tried to get the introduction about what is economy and what are the components of an economic system, such as economic agents, what are the institution, what is the role of market, which is to link the agents and institutions. So, institution is the one who set up the rules so as to shape the behavior of various economic agents. Economics agent can be any individuals or firms. So the economic agent consume or produce various goods and services. Then we have tried to understand the interlinkages by this diagram. So here we have said that the production of certain uh, goods and services, and then there is a consumption part, and then the production, for the production of any goods and services, the supplier of energy and material is from environment. Then once the production process starts, then there is a certain waste which are being generated, which is dumped in the environment. So environment acts as a vesting capacity, which is its second service. After that, the consumption of goods are being done. However, there is wastages, which again comes into environment as a wasting capacity. So the wasting capacity includes the air in which we emit various uh, pollutants. It can be ocean, it can be landfills, mountains, and etc. And then the third service the environment give us is the amenity value, that is the beauty of nature, or the environmental essence which we get through which we get certain happiness. So that is what we have tried to understand. Then we have said that E4, like that is the uh, total combination of E1, E2, and E3 have to be maintained so as to maintain the overall environment and ecosystem. So, however, you cannot extract unlimited supply of energy, material, or you cannot use the wasting capacity to unlimited level. So, to get the optimal level of E1, E2, and E3, that how much percent of energy we can extract out of environment, how much percent of environment we can use as a wasting capacity, however without reducing the amenity value, like without much affecting the nature. So therefore there is a requirement of study of environment and economy together. Then we have tried to justify the requirement of environmental economics through the utility function. So in the utility function, we have utility as a function of marketable goods and environmental goods and services. In marketable goods, it can be various services such as food, shelter, clothes, or various other services which we extract. And then in environmental goods, it can be like air and water quality, environmental cleanliness, access to clean drinking waters, and etc. So let's take then we have taken an example of individual whose utility is that he loves driving car. However, the air quality is being impacted because of which its environmental goods and service part Q component is being affected. So what is the optimal value of uh, marketable goods which we can consume without much impacting the environmental goods and services, so that our utility function is maximized? So that is the justification of environmental economics, that we are trying to see the trade-off between environmental quality and production of marketable goods. If there is any question, then you can interrupt me in between. Okay, then in the next module, then we have tried to understand what is EKC curve and what is EKC hypothesis, how how the curve we have obtained, what are the explanations, and then we have tried to understand the limitations of EKC hypothesis, and then what are the policy implications of EKC. So here EKC is the curve which we plot between the emission per capita and income per capita. The postulate states that with increase in per capita income, initially there is the increase in emission per capita. However, after certain point of X star value, there is reduction in the emissions. So here we are saying that the economy itself is taking care of the emission. So the explanation of EKC curve includes the linear growth of economy, like the growth is because of the shift in economy from agriculture sector towards the growth of manufacturing sector, which is energy intensive. So energy intensive, so it produce higher amount of emissions. After that, when the country's per capita income is increasing, then the service sector blooms up. So there, the production is cleaner. Therefore, the increase and reduction is explained first by linear growth of economy and then the scaling effect. So the scaling effect means with increase in number of production, there is increase in emissions. So if you produce certain numbers of good, let's say chair, then for each chair there is emission which is being linked. With increase in production of number of chairs, there is more emission which is being done or there is more environmental degradation. So uh, the scaling effect is always positive in the first part as well as the second part. However, the technological and composition effect, like let's say that when a country is developed, the environment is given more importance. So we move towards the efficient technology, cleaner technology, and better composition of various production goods. So from there, the technology and composition effect will be higher in terms of developed country. When income per capita increases, the third and fourth component will be more than the second component. Therefore, the trend of emission decreases. And then there is another explanation, that is international trade. So the developed country have stringent policies for emission standards, right? So what happened is many of the investor try to invest in the developing country so as to avoid the payment of various environmental emissions that they are doing or various standards they have to meet in the developed country. So to avoid this investments, they move towards the developing countries. So this concept is known as pollution heaven hypothesis, where the emission of developed country move towards the developing country. And then we have said that the capital theory of EKC. So when a country is developing, the economy is given more importance, economic growth is giving more importance. However, when a country is developed, then they give more importance towards the pollution abatement. So therefore, the overall overall emission reduces with increasing per capita income. Okay, then we have tried to model the EKC curves. So here YIT is our environmental degradation parameter. It can be air quality, water quality, amount of CO2 being produced, amount of SO2, sulfur oxide being produced, and then alpha, beta 1, beta 2. These are my coefficients, and XIT is my per capita income. So according to the value of alpha, beta 1, beta 2, we get various types of curve. So if all the parameters are more than 0, then we get linear kind of growth. Then when the alpha is more than 0, beta 1 is more than 0, and beta 2 is less than 0, then we get EKC kind of curve. And then the third one is the inverse uh, inverted U-shape, U-shaped or inverse EKC curve, which we obtain if alpha is more than 0, beta 1 is less than 0, and beta 2 is more than 0. So these are various cases of coefficients when we plot the value of environmental degradation factor with respect to its per capita income. So after that, we have tried to learn few of the basic principles of economics, including supply demand curve, utility function, indifference curve, and then marginal what is marginal rate of substitutions, and what is the economic definition of externalities. So moving on to the today's session, I think I'm audible, and if you have any comments, you can post in the group. Sorry, you can post in the chat box, or you can interrupt me at any point of time. Okay. Now we will move towards the week two session. So first in week two, in continuation with the EKC curve, here we get here the EKC curve is given by this relation where YIT is equals to alpha plus beta 1 XIT plus beta 2 XIT squared plus UIT. So, sorry to mention, UIT is our error parameters. So, there are many other parameters which YIT might be dependent rather than per capita income. So, UIT will try to capture the error term in the relation between these two components. Now, what is turning point? So, turning point is the X star value where the value of per capita income will be X star. After the X star per capita income, then we are assuming that the emission will be reducing and emission will be downward sloping. So, to get YIT, we are differentiating this equation with respect to XIT, and then we are uh, equating it with 0, then we get xit optimal, that is minus beta 1 upon 2 times beta 2, right? So this will be our optimal value of per capita income beyond which we are saying that the emission will be downward sloping. However, the value of turning point might be dependent on various pollutants you are capturing in YIT, the composition of sample, and the time period. So now we'll discuss about the limitations of EKC hypothesis. First of all, what are the indicators which are being used for environmental quality? So we are saying that YIT is the parameter for environmental quality, right? So what are the indicators which we can take in place of YIT that we are trying to understand? So YIT can be air quality. So air quality is measured by the amount of pollutants in the air. So the pollutants can be either global pollutants or local pollutants. So global pollutants are those pollutants in the air which do not pose any direct impact on your health or direct impact on you as a person. However, it have gradual impact on the overall climatic conditions and all. CO2 is the example of global pollutants. And then what is local pollutants? Local pollutants are those which have direct impact on health, such as a sulfur oxide, which is being emitted out of coal-based power plant, and nitrous oxides of various forms, and then carbon monoxide. So local pollutants and global pollutants are one of the parameters which will give us the environmental quality. Higher the pollutants, lesser will be the environmental quality. Then we come towards the water quality. So the water quality is measured uh, by the amount of organic components in the water. So higher the amount of organic components, we say that the water is more polluted. So biological oxygen demand and chemical oxygen demand captures the water quality as well as the amount of pathogens or amount of heavy metal content in the uh, water can be few of the indicators. After that, there are many other indicators such as municipal wastewater and then access to safe drinking water. So access to safe drinking water can be captured by the groundwater level and then the deforestation and etc. Is there any question?
No, ma'am.
Oh, uh, am I on the right pace? Like, shall I fast up or shall I make it little slower?
No, ma'am, you are on a right pace.
Okay, thank you. Now we are testing the EKC hypothesis on various indicators which we have mentioned here, that is air quality, water quality, and others. So when the EKC hypothesis is being tested, like we have uh, certain curve which is being plotted. So if we see the validity of EKC curve, then EKC curve is found valid for local pollutants, including sulfur dioxide, NO, nitrous oxide, and then carbon monoxide and suspended particulate matter in the air. However, EKC hypotheses do not hold true for all the global pollutants such as CO2. So for global pollutants, there is the relationship of monotonically decreasing or increasing relationship between emissions and per capita income, which uh, in turn says that the EKC curve we do not achieve. Then water quality indicators. So for water quality indicators, we have several indicators. However, uh, the test is that there is mixed evidence of EKC. Few of the few of the indicators shows U-shaped. However, there is inverted U-shape as well as various other curves. So there is no evidence that whether EKC does follow or not. Okay, now the bigger question is that is EKC permanent? Like we are saying that the downwards, we are assuming that the declining in environmental quality is temporary. Like let's say that there is increase in sulfur dioxide in the environment. However, the economy will take care of itself. Like we will adopt some technology after a certain level of per capita income. After which we will say that the emission will reduce. However, there are the biggest question is that is the downward slope permanent? So we are saying that so now the downward slope we achieve because of various technological invention or various adoption of cleaner technology, more efficient technology. That is because of structural change, or the structural change in the production process may not be feasible for various for all types of pollutants. So for that, what we do is we try to reduce the emissions. So per unit emission reduction, we are trying to reduce. However, after certain point of time, we reach to the end of pipe where the marginal cost of reduction of emission is very high, that it's not economical to reduce the emission. So for those kind of pollutants, what happens is after the certain point, the emission will again try to increase because it's not economical to reduce the emissions, right? So when the cost of abatement is too high, environmental quality will start deteriorating again. So the for many cases, we are saying that the EKC hypothesis is not permanent, may not be permanent. So that means that the downward fall and then there is upward swing. So upward swing can be very exponential as well as steady. So then this leads to the N-shaped EKC curve. So okay, uh, good evening once again. So we are uh, trying to understand the lecture first of second week sessions. So now we are here. So we once again, there is two more person who joined right now. So I'll repeat it in shorter way. So we are saying that EKC is not permanent all the time because EKC is not permanent all the time because the downward slope may leads to the after a certain time leads to the uh, fast increase in the emissions after the downward slope. So that's why we are saying that the when the when the pollutant is the one which does not follow the structural change, however, the cost abatement are being done to reduce the pollution. So we are spending per unit emission reduction methods so as to reduce the cost. However, when we reach to a certain point where the reduction in cost is very high, then the environmental will again start deteriorating. So that's why we are saying that EKC is not permanent. However, there are few cases in which the downward after the certain downward trends, there is fast increase in the emissions. So that is till the transition period. Let's say that. For now, we have certain capacity of renewable energy through which the environment, like by adoption of environment, so, so here we are saying that when let's say that we have a plant which produce uh, number of which produce electricity with lesser production of sulfur oxide because it have technology to capture the emission of sulfur. However, after 10 years, the plant will retire, or let's say that the plant produce certain level. However, there's requirement of more electricity, and the cost of capturing the sulfur oxide becomes very high. Then what will happen is that the emission of sulfur oxide will increase. So in such kind of cases also the increase or the steady slope of N-shaped EKC curve we are obtaining after the downward slope. So that is what we are trying to say, that EKC might not be permanent. After a certain level, we need various technological innovation or interventions of technology, or there is requirement of plan that after certain level how we will adopt cleaner technology so as to avoid the uh, incremental emissions after certain level of economy. So the second question is, does EKC follow sustainable path? So EKC is a flow concept which gives the relation between per capita income and emissions. However, the environmental quality of a nation of a overall system will depend on the stock of pollutants. Let's say that in 1900s, uh, emissions of CO2 will impact lesser as compared to right now. So the stock of pollutants is higher right now, because of which the impact will be higher. So EKC do not capture this stock of pollutants concept. Let's say that after some time, let's say that if we say that we are having a lesser per capita income, India is having lesser per capita income, and right now our economy is not enough to reduce the emission. Uh, However, at certain point of time, the environment will not be able to regain its sorry. However, the environment will be irreversible, will follow a irreversible path. Let's say that now global warming will be happening. after that there is more emissions of CO2, let's say, then the trend will not follow. So they the stock of pollutants in the environment which is already there will impact the environmental quality. However, environmental cushioness curve do not capture this concept. So therefore, that is one of the uh, limitation of EKC. Then second is EKC is not necessarily applicable for measuring sustainable development. So this is one of the reason that when there is irreversible changes in the environment, then the impact there will not be the sustainable development. So that's why one of the reason. Then next one is that we are generalizing X star, that is the per capita income, after which the emission will take care of itself. However, there might be the cases that the marginal benefits and marginal cost of pollution control is more important compared to the per capita income. Uh, let's say that there's a place where the economy is not that much. However, there is lots of pollutants, that there is requirement of reduction in pollutants, because the particulates matter. Let's take the particulate matters as a pollutant. So if the amount of particulate matter increases, the impact will be on the health of a person, right? So the marginal benefit, if it is high, then the country or the government will be ready to reduce the pollution, right? So in these cases, marginal benefits and marginal cost of pollution control will be more important than the curve which followed. So the curve will not hold true when in this kind of cases. Then third one is that we are generalizing the turning point, that is X star. So that is what I have mentioned right now only. So we are saying that for all kind of country, the X star will be a certain number for each of the indicators. However, that might not hold true for all the countries, because different countries have different structure of government, socio-economic development path, or social norms, various kind of regulations, various importance levels towards their environment. So based on the government, based on their regulatory structure, policies, the turning point might be different for different countries or different economy, which the EKCs failed to capture. Then the next one is heterogeneous characteristics of different countries. So what we are doing is we are getting one value of alpha, beta 1 and beta 2 for all the countries by capturing a pool data of emission per capita and amount of emission. So uh, one size will not fit all the country. So the growth trajectory which we are assuming that with certain level the emission will reduce, that will not hold true many of the time. Then the concept which we have already told in the first point, that improvement in the environmental quality is possible only till the point where there is reversible in nature. Like when the environmental degradation is irreversible, then the environmental quality will not be better. So that is what it is trying to say. So if there is any question, then you can ask me. Okay. Is there any question?
Not from my part.
Okay. Is the concepts clear, or do I need to explain it better or anything?
Ma'am, it's clear. No problem.
Others, do you have any question or anything? then you can tell me. Okay. Then to make it little interactive, I'll try to go to a question. Okay. Can we just discuss a little bit about the EKC curve and its limitation among ourselves, if you are comfortable? Like, we will just try to give. I'll hear what is your what is your understanding about it, and we'll just discuss a few of the points. So, anyone wants to make any statement about it or anything? So, we have till right now we have asks two biggest question, that is that EKC is first of all, EKC is not applicable for all the indicators, because there are for local pollutants it is applicable, however for global pollutants it might not be applicable. Then can I get the reason, like why do you think that for local pollutants EKC hypothesis is valid, however the for global pollutants it's not applicable? So why do you think that it is as such?
Is it because we don't know the source of the pollution, like which country is polluting? Like
Mm,
pollution emission emitted in USA might go to like Canada and might get recorded there, right? So we don't know the
mhm.
source.
Yes, yes, that is correct. That, let's say that for local pollutant, if it is increasing and the economy is increasing, then the government will take some action, and then the feedback also will get in a certain way, right? But for global pollutants, even if you try to reduce the CO2, even if a country try to reduce the CO2, but there might be other economy for whom the emission will increase. So overall impact we cannot capture through EKC hypothesis. So you are correct. Anyone else? Okay, then so if you have any questions, then you can ask me. And this is like little bit long slide. So if you want to look into it, if you want to discuss, or if you want to uh, give some points, then you are welcome. So overall, we are trying to say that EKC is not necessarily the measurement of sustainability. So even though we follow EKC kind of trajectory, the path might not be sustainable, because let's say that India is achieving its X star at 2050 for a certain pollutant, let's say sulfur oxide. However, at that time, the environments already have a lot of emissions, like let's say sulfur oxide in the environment. Then during that time, will the emission be possible? So the what is the abatement cost, and is it possible? Is the impact reversible or not? Are we making irreversible impact on the environment? That is what we are trying to say through N-shape EKC curve. And then the another thing is that when we try to draw the relationship between this YIT with respect to per capita income, then we are taking all the economy, including America, US. So all the country are pooled in one, and then we are trying to see the environmental degradation with respect to per capita income. However, different countries might have different trajectory and different level of extra. So that is another drawbacks of EKC curve. Okay, now, so out of all this, what are the policy implications which we make? Like, can all the country follow the EKC curve and do the policy, like make their policy so as to take care of their economy as well as environmental quality? Can all the country do that? So what is the policy implication out of EKC curve? If you are a policymaker, then what will be the biggest takeaway out of this limitations which we have learned? You can write in the chat box or you can speak up. So for any country, what are the factors that they have to take care other than following EKC curve? So why EKC curve cannot be followed blindly? So that is the simple question. Can I get some answer from, yes, ma'am, Pujarini, ma'am? Yes, you can speak up. You are muted. Hello. Or you can write in the chat box if you want. So my question is, what are the policy implications a country or policymaker have to take away from the EKC curve as well as its limitations? So Vinod, can you please give me the answer? Okay, Krishna sir, can I get your answer, please?
You don't have to call me sir. I'm a student.
Okay, okay, so, okay.
Yeah. So like, I think policies have to be made indicator specific.
Uh-huh.
That's what sir said in the class. So
Yeah,
I
yeah,
don't.
yeah, yeah, yeah. Sorry. Okay, that is correct. That policy have to be indicator specific. That is one of the biggest. And then, like, okay, the thing is that we are actually trying to discuss the whole thing which is captured in the class. So to make it more interactive, then I need your input also, so that we can discuss over some of the things and we try to share our knowledge with each other. So for that, I need more interactions from all of you. So first thing, Krishna had mentioned that the policy have to be indicator specific, since EKC is applicable for certain indicators. However, it's not applicable for all the environmental degradation indicators. So after that, can I get from Pujarini? Okay, Haresha. Haresha sir. Okay. Uh, D, the person with username D. Okay, then I'll move to my slides only. Okay, the biggest takeaway is that we cannot blindly rely on EKC paradigm because we are assuming that the growth will take care of all sorts of environmental problems. However, it might not be true in all the cases. So the policy should be made taking into consideration all the other things rather than just saying that the now we are at the growing stage. After some time we will adopt better technology, cleaner technology, or we will increase the uh, regulations on emissions so that our emission comes down. So that might not always fall true because once the environment is degraded, or it will take for if it takes forever to reduce the emission, then it might give negative impact on the overall ecosystem and environment. So that is first point. And the second point is that EKC is not valid for all type of indicator, as Krishna had mentioned. And then the time, like at which X-star will be achieved. So that is not mentioned in the EKC curve. So what if it takes forever, or it takes hundreds of years to achieve that X-star? Then the emission will increase steadily. So that will lead to various degradation in the environment, and we will not get sustainable future. So for this limitations as well as the methodological limitations, so here we have mentioned that here what we are assuming is that, sorry, what we are assuming is that the per capita income have a unidirectional impact on the environmental degradation. However, there might be some cases in which the the uh, because of environmental degradation, the per capita income is impacted. Right? Let's say that there is a crop which is grown in certain kind of environment and certain kinds of air condition. However, when the emission increases, or then the temperature rise at this place, then the environmental degradation will increase, right? Because of which the temperature is increasing and amount of pollutants in the air is increasing. However, there is impact on the crop production. So there is the unidirectional assumption that per capita income will impact the environmental degradation. However, environmental degradation may also impact the actions of various economic agents, because it may impact positively also in sometimes, like let's say that the environment is degrading, so now we move towards the cleaner choice of technology, or we go towards the recycled items. So that might also be the case. However, the EKC is assuming that there is only unidirectional impact of income and emissions. So that is one of the things. So for this, other econometric tool have to be used to formulate the problem in which the interdependency between the per capita income and emission is captured properly. Then the random coefficient should be applied. So here we are saying that beta 1, beta 2, and alpha, we are getting certain numbers. However, this can be random for different economy, different countries. So by using panel data, data is having time series, uh, uh, number of times, and then individual wise varying data kind of thing. So pool data is you pool all the, let's say that SO2, like sulfur oxide content, and then the per capita income. So if you club all the SO2 content and then all the per capita income, then you will get the pool data. However, the panel data and the random coefficients method have to be implemented so as to get the better assumptions of the model. So that is one of there are two methodological limitations of EKC. Okay, then conceptual limitation is that EKC is obtained using pool data. So we cannot say that when the overall reduction in the emission is there, it might be because of the shift of emission from uh, uh, shift of emission. Like there is no overall reduction in the emission. However, the environmental regulation at developed countries are more stringent. Therefore, their emission reduces. This leads to the downward trends of emission without overall reduction. So that might leads to the that is the another question that overall sulfur oxide is not reduced. Overall per capita emission is not reduced. However, the developed country are contributing more in the reduction of emission, because of which the downward trends is coming. So this can be one of the limitations. So therefore, because of all these limitations in its methodology assumptions, we are going towards the discussion of sustainable development. So, am I clear? Can I get some questions if you have?
Ma'am, I had a question about the turning point.
Yes.
Like it is given for a time t, right? So does it like shift every year, or how is the regression done like exactly for exciting?
There is that turning point which you are saying. Here, right? No, the turning point is at a specific time, like at a specific income level, like. So that is not time dependent actually. That is beta 1 and beta 2 are coefficients, right? So these are constant numbers. So the turning point is not time dependent. However, turning point is achieved for each of the environmental degradation factor. Let's say that uh, we have collected the data of sulfur oxide production and per capita income. So we are pulling the whole data and then we are running the regression. So then we get the value of alpha, beta 1 and beta 2. So from
Yes,
that we are trying to get the value of x star. So x star will be our minus beta 2 upon 2 times, sorry, minus beta 1 upon 2 times beta 2. So that is not time dependent.
okay, thank
Yeah.
you.
I think I have made the mistake that I should not have denoted like this. So it will be x star only, that at a specific per capita income, then the turning point will be there, after which there will be downward sloping, right?
Yes, ma'am.
Uh-huh. Mm. Now, now we are going towards the sustainable development. So we have concluded that EKC is not necessarily the measure of sustainable development. So then how can you define sustainable development? What is the economics of sustainable development? How will you measure it? So that is the concept which we will try to learn in the next section. Okay, so first of all, we have tried to understand the difference between economic growth and economic development. So the economic Growth indicates the physical increase in the country's income, which can be measured by GDP, GNP, NDP, NNP, or etc. Like what is the overall increase in the country's income? So that is captured by economic growth. However, it's not necessarily that if a country is rich country, all the person have equal amount of equal access to the infrastructure, equal access to the economy. So then comes the economic development part, which indicates the distributional aspect of growth. If the economy is increasing, what is the per capita income? Like, what is there equal distribution of economy or not? So, for any country, the economic development is necessary with the growth of economy. So, to ensure the economic development, we incorporate various policies to implement the proper distribution of economic growth among all the citizens so as to get the benefit for all the citizens in terms of its uh, standard of living and all the necessary benefits the citizens get. So that is the two different concepts or definitions which we have. Then the income. So income. So there is a difference between income and earning. So earning is what I earn in a month or in a year. So that will be my earning. However, income is defined as maximum proportion or amount from earning which I use so as that my well-being right now will be equal to the well-being at the end of the period. Let's say that this month I'm getting 10,000 rupees. So my initial utility or my initial earning is 10,000. So if I spend all the 10,000 at the start of the month, then at the end of the month I will not have any money, right? So my well-being at the start and the end will not be equal. So the income will ensure that let's say that out of 10,000 I invest 4,000 in certain kind of stocks or anywhere. Then at the end I'll get the benefits from my stocks. Then this will ensure my well-being, right, or ensure my satisfaction or my happiness at the end of the period. So that is the definition of income. So now we are trying to connect the income with the sustainable development concept. So therefore we are trying to learn the definition of income. So now what is a sustainable development? So sustainable development is the development that meets the need of present generation without compromising the ability of the future generation uh, to meet their need distributed on the basis of equality between present generation and future generation. So what we are saying is that uh, the current generation is using certain amount of uh, resources or certain amount of raw materials. However, the uh, future generations access to the resources should not be compromises. So the development which we focus with taking care of the need of future generation can be termed as sustainable development. Then now the if we compare the EKC and sustainable development, so EKC is more of a efficiency, like after certain limit we will try to improve the efficiency so as to reduce the emission. However, sustainable development is equity concept in which you keep certain amount of resources to the future generation so as to meet their need and growth. So that is uh, that is one of the concept. And then sustainable development emphasize more on the equitable distribution of resources between present and future generation. However, the efficiency will impact sustainable development, because if you improve the efficiency, then you will have more amount of resources. So you can either use in the current generation, or you will get more amount for the future generation. So indirectly, efficiency will impact sustainable development. However, sustainable development is that how much amount of resources you will extract right now. However, you will not over extract, because it will impact the future generation. So to keeping in mind them, then we are trying to extract the resources, or we are trying to develop our economy. So that is sustainable development. So in concept of economy, we assume that every individual is selfish and they try to maximize their utility. So if we say that all the individual are selfish, then how come anyone will try to think about their future generation? Because I, all the individual will try to extract the maximum benefit out of the resources which we have, without following the need of future generations. So this we are trying to explain by two concepts. First is utilitarian function, in which the social welfare, in which the concept of maximization of social welfare is there. So what is social welfare? Social welfare is the summation of utility of individual 1 to n from time 1 to time t. So you are summing up the utility over the time. So that's why we get the social welfare. And R is the discount rate. Let's say that in the future the rupees is 100. So you are discounting it to the net present value. So therefore you are using the term 1 by 1 plus R. And then the second explanation about the need to bother about the future generation is that it is our moral right to protect the environment, because the future generation have also right to enjoy the benefits as much as the current generation is enjoying. So that is philosophical point of view, that it is our moral right to protect the environment, because they also deserve as much as clean air we are enjoying, the as much as clean water we are enjoying, as much as forest like nature we are enjoying, or as much as raw material we have extracted. So certain amount the future generation will also uh, need it. So that is the definition. And then now economic definition and measurement of sustainable development. So if there is any question, then I can address it, if you want to discuss about anything. Can I get some questions or any comments which you want to make, or any discussions on which we can talk about? Okay, then now we will discuss the economic definition of sustainable development. So the sustainable development can be measured in terms of outcome-based approach. Here, what we are saying is that for sustainable development, consumption should be non-declining, and environmental quality should be non-declining. So the utility function is the function of consumption and environmental quality. So what we are saying is that over the whole period of time, right now, in the future, the consumption have to be non-declining, and then the uh, utility function have to be non-declining, and the consumption have to be lesser than certain maximum value, which uh, which the production level will achieve. Like let's say that the as U-shape uh, EKC curve, the consumption curve is also such that it will initially increase, achieve the maximum consumption, and then reduce. So the in outcome-based approach, the we are saying is that the utility function have to be non-declining, and then consumption have to be non-declining, and there is a limit in the consumption which you are doing. So that is the definition. And then in the means-based approach, what are various means of production or factors of production which we have? So it can be physical, that is various man-made products which you make, and then human, that is labor capital, and then a social, that is the trust you achieve, or various social work which you do so as to benefit the firm's business, and then the natural capital. So natural capital means various renewable and non-renewable resources which you have. So these are various factors of production. So in means based approach, what we are saying is that for any point of time, the total capital stock have to be non-declining. So either the sum of all the capitals have to be more than zero, or individual capital have to be more than zero. So that is what we are trying to say. So in this, what we are saying is that if you are using certain level of natural capital, then it have to be converted to the physical capital. So in this way, the overall capital stock function is non-declining. Okay. So then we have a weak sustainability rule, which states that the total capital stock is constant. So in here, we are overall saying that the total capital stock should be non-declining. And then here, in constant means what we are saying is that, let's say that we are using certain amount of natural resources such as coal or anything. Then we make certain kind of man-made products, right? So the overall capital have to be constant. There is only the substitution between one capital to others. So that is what we are trying to say. And then we have the concept of economic rent. So every unit of economic rent derived from the extraction of natural capital should be reinvested in man-made capital to get the equivalent amount of Km when Kn goes down. So overall, the Km and Kn are substituting each other. So economic rent is the function of price of natural resources minus the marginal cost of extraction. So from here you can get the economic rent. Then this rule is known as weak sustainability because it allows the substitution between the one form of capital with other form of capital without much stringent restrictions. Next one is what are the limitations of weak sustainability? So we are saying that the natural capital uh, will be substituted by man-made capital. However, it might not be possible in within the certain visible time frame, or it might not be possible all the time. So that is one of the limitation of this rule. Next rule is here what we are saying is that we are assuming Cobb-Douglas type of production function in which the utility function is equal to Km times alpha and Kn times 1 minus alpha. So the elasticity of substitution of Cobb-Douglas type of production function is 1. So what we are saying is that Km and Kn are perfect substitution of each other. So as discussed, this might not be the case all the time. So that's why we are saying is that that is one of the limitation. Next is we are assuming the sum of all the capitals. However, all the capitals will might have different units. So there is a requirement for aggregation. So let to aggregate it, what we do is uh, we give the monetary values to each of the capitals. However, the monetary value cannot be given to the natural capital Kn, as there is no direct market for K. So that is one of the limitation. So this is about the weak sustainability. So if there is any questions, then you can ask, because the if you haven't covered the lecture, then it might be little hard to catch up. So you can ask me any questions, or you can comment on any point which I've mentioned. You can raise your voice, raise your hand, or just speak up. Krishna,
Yes, ma'am.
do you have any points to add, or any suggestions or anything on the definitely from definition of sustainability towards the uh,
Yeah.
towards
So like,
mm,
uh, can you go to the slide on social welfare? I have a
mm,
question about the formula.
yes, yeah,
Yes.
right,
So basically, the time periods range from 1 to T, right?
yes.
So I want to ask, why are we just discounting it one period? It isn't it supposed to be like 1 by 1 plus r power T or something?
That have to be 1 plus r ki power n, because if we are discounting time 2, then it will be power 2, right? So
Yes, ma'am. Yeah, that is what I want
yes,
to
yes,
ask.
yes. Yeah, that should be the case. But I have just followed what sir had mentioned. But yeah, you are correct. Because let's say that if the year is 2 or 3 or n, then you have to take the power as n, because each year you are discounting, right? So yes, that is correct.
Yes, ma'am. For like 2 years, it would be like 1 by 1 plus T, r
Ye-
square, and so
mhm.
on.
Yes, yes, yes. I agree on this. And anything else you want to?
No, that's just this.
Where n is our time, like let's say I'll write one. Okay, then is there anyone else who can comment or who can ask any questions? Or you can share your own understanding about the subject or about the lecture which we are covering right now. So Vinod, are you there? Harish, Harisha, is there anyone else who is active with the lecture? Okay, then I'll continue only. Uh, so we have talked about weak sustainability. So then we have talked the 3 points, and then the how can we aggregate this term, and then the challenges we still face after that. Then we come to the production versus consumption substitutability. So can we substitute production value? Can we substitute consumption value? So production substitutability is to some extent possible. However, consumption substitutability is not possible. For example, we cannot substitute the amenity value by building certain kind of tower. So that is one of the example that the environmental quality cannot be the amenity value cannot be substituted with any kind of other capital. So that is one of the limitation. After that, the another limitation is irreversible impact on natural capital. So what we are saying is that the natural capital and the man-made capital are perfect substitution of each other. However, if we impact on natural capital very much, then the coming back to the ground zero or to the initial level might not be possible. So that is one of the limitation which we face from weak substitutability rules. Now we go towards the strong substitutions of sustainable developments. Here it states that the stock of natural capital should be constant. So initially in big substitution we are saying that Kn and Km are substituting each other. However, in this we are saying is that what we are saying is Kn is constant and it have to be Kn should be constant. So natural capital have to be constant and it cannot be substituted by man-made capital. So that is what I've mentioned. And then this is called strong because it is imposing a stringent restrictions to maintain the certain level of capital stock, which is constant. And then it is also stringent because it says that critical capital Kn star should be constant for various ozone layer, climatic condition, atmospheric composition, and etc. So here also the problem of difference in the unit is there. However, let's say that we have Kn1 as number of wetland, and then forest, and then oil deposits, and then coal value, and etc. So to aggregate the values, what we are saying is that uh, each of the natural capital have to be constant. So that is what the compartmentalization means in this. And then the implications, like what does strong sustainable development means. So here what we are saying is that Kn should be constant. So if Kn is constant, then how will we build certain kind of infrastructure? How will we focus on our economic growth, or how can we draw a certain service from the environment? So that is the question. So then the summary is that we cannot develop projects by strong sustainable development, because we are saying is that what we are saying is that the capital natural capital is constant. So the solution towards this problem is that first is shadow project. So same amount, like let's say that if you are constructing a road, then or if you are constructing any kind of if you are cutting some forest and constructing a building or anything, then equal number of tree uh, have to be planted in the other place or anywhere else, so that trying to you are trying to compensate the environmental degradation which you are doing. However, many a times let's say that you are cutting 100 trees, that is over the age of 100 years to more more year trees. However, if you are planting tree right now, then it will give lesser service compared to what you have destroyed. So these are not equivalent. Then comes the second kind of solution in which we are saying is that let's keep a certain package. So you can use this much amount of forest, you can cut this forest. However, the forest cover of a country have to be this number. It cannot be lesser than this because it will impact the ecosystem, it will impact the animals, it will impact the wildlife uh, and the climatic condition of the place. So that is safe minimum standard which you can use for the project development. However, you have to keep other bundles uh, so that the regenerating capacity, you are giving the economy time to regenerate itself, so that you do not reach the point where the environmental degradation is irreversible. So that is what we are trying to understand from the SMS growth. So that is all. Now I need more interaction from all of you. Uh, how many of you are there? I'll just pose the question and then please give the answer in the chat box if possible. So first one is the turning point of EKC curve occurs between this to this. So you have to answer it A, B, C or D. Then I'll just do this. I'll just give you the answer after that. So EKC curve, what is the turning point which sir had mentioned in the lecture? Okay, I'm getting A from the north. And anyone else? Okay.
No, ma'am, not A. It is between 3,000 and 10,000.
Okay. And what is the constant price that they have assumed? What is the year?
1985.
Yeah, so yes, so this is E because the am I audible? I think. So this is
Yes,
E
ma'am.
because
E
in
stands.
in A the year is it is 3,000 to 10,000, not 5,000, and this is the optimal value which EKC curve had obtained. So that is X star value which we have discussed right now. So is it clear? So it's a number which they have drawn out of econometric methods. Then next one is for local pollutants, the relationship between emission per capita and income per capita is. So please put your answer in the chat box. For local pollutants. Okay. Uh, anyone else is there? Yeah. A. So is it for the second question? I'm assuming. Right, Vinod and
Yes,
yeah, for the
for the second
yes,
question.
yeah. That is correct. That for local pollutants, it is EKC type, right? Then if I ask for the global pollutants, then which point will hold true? The same question. However, if I ask for the global pollutants, then what will be the answer?
C, ma'am, monotonically increasing or decreasing.
Yes, that is correct. So then we will go to the next question, which is which of the following is not the limitation of EKC hypothesis? So which is not the limitation. So you have to give any choice. Yes, this is correct. Anyone else? Yeah, third is C, right? So this is the overall characteristics of EKC curve, but it does not give the limitation as such. So EKC curve is inverted U-shaped relation between income per capita and pollution. So this is not a limitation. Okay, then next one is sustainable development is defined as keeping more resources without bothering much for present generation, using maximum resources for the present and keeping less for the uncertain future. And then third is meeting the demand for present generation without compromising the need for future generation. And then none of the above. So that is quite simple questions, but okay, this is right. Next one is so we have defined sustainable development as this only, right? That we are meeting the current generation's demand. However, we are keeping certain amount of resources for the future generations so that their needs are not compromised. So that is why the option C is correct. And next is if elasticity of substitution between natural capital and man-made capital is one, then it is strong, big, very strong, sustainable development. So that we have just mentioned in the lecture. So 6 is 5 is C, 6 is okay. Any more? So this is very direct kind of question, but still, just a recap. Yes, that is correct. And any more person? Okay, then we will move to the next question. Okay, now this is a calculation which I want you to do. So here we have given the marginal resource rent for the natural resources, which is given 500, and cost of extraction is given 150. Then the unit price of the resource should be. So I've mentioned a formula in which the resource rent is given. So from there you can calculate. Okay, any more? Okay, so this is a very direct kind of questions which we are discussing. So here I will tell you the answer. So the resource rent is given by unit price minus cost of extraction. Here we are given the resource rent and cost of extraction. So to get the unit price, we will sum both the component, then we will get 650. So, okay, next one is sustainable development means maximizing the economic growth, income inequality, the productivity of produced asset, or none of the above. So, okay, um, okay, okay. Okay, the anyone else? Anyway, I'm getting three answers only from you guys, so we got the answers. So the correct answer is, sorry, the correct answer is none of the above. So why it is so? Because we have defined sustainable development, right? So in sustainable development, we like if we define properly, then it's not only about economic growth, because we have to uh, focus on the present generation as well as future generation. So uh, first part is not correct, and then the productivity, the income inequality though does not make sense, because why are we trying to maximize the income inequality in a economic system? So that is not the correct answer. And then the third part is that productivity of produced assets. So if we try to increase the productivity of produce asset, then it's not called sustainable development. So that is why the answer is none. But yes, economic growth is there in sustainable development, but we have to focus on economic growth while keeping certain amount of resources, or while limiting the resource extraction, so as to benefit the future generation. So that's why the correct answer is E. So I think I'm clear. Oh, sorry. Then last one is economic development, right? So what I have mentioned, what is the difference between economic development and economic growth? Can you say, can any one of you unmute and say? With an example, you can say also, like, what is economic growth and what is economic development? Mm, I am
How can
not.
I answer the
Yeah,
question?
please. Yes, yes. So,
So
yes.
I think that like growth is measured by GDP. It's more to do with the increase in GDP and like all of that. Whereas
Mm-hmm.
development is measured by indicators like HDI. It refers to human
Yes.
development, and you
Yeah.
can have high GDP but like low human development, and you can
Yes.
also have
Yes.
vice versa. So yeah.
That is true. HDI is one of the indicator for economic development, because how the human development is there, what is the excess of different benefits to the uh, normal citizens. So that might capture the development in better way than overall growth in the economy, right? So yes, thank you for mentioning HDI. And Pujarani, am I pronouncing it right? Can I get your view on the uh, today's session, or on specifically on the economic development, sustainable development, and EKC curve? So, what are these three things from which you like? How can you differentiate these three concepts? So, can I get the answer from Pujarini? Okay. Mm, Okay, so economic development refers to the economic growth plus changes in output distribution and economic structure so as to get the equitable distribution of economy among all the people. So the first one is incorrect because there is a difference between economic development and economic growth, right? As we have mentioned. And then the third one is incorrect because it have mentioned only the urban population, so that's why it is incorrect. And last one is sustainable increases in GNP. So first of all, gross national product will give us the economic growth. So that's why it does not define the economic development. So am I correct? Sorry, am I clear? Okay, next. These two questions fast. Heartbeat rule of weak substitutability uh, is depends on the substitutability between the physical capital and natural capital, and then the goodwill of future generation. The third option is the substitutability of different forms of physical capital, and fourth one is maintenance of physical flows of certain key individual resources. And then the last point is the non-substitutability of physical capital and natural capital. So which one is correct answer? Okay. Anyone else? Can I get answer from any other two-person? Actually, there are 10 people who had joined, but I'm not getting any response from. I'm getting response from only 4 person. Other than this, I'm not getting. Okay, Vinod had answered, and then Ucharini, can I get your answer? Okay, I get one more answer from. Mm, I'm sorry, I'm not able to. It's actually Paul. And then, yeah, so so you are saying yes, so the substitutability of physical and natural capital uh, will the weak sustainable development rule will be depend on this two and their substitutability. And then the next options which you have, such as substitutability between different forms of physical capital, is incorrect, and goodwill of future generation will take care in sustainable development. And then the uh, option D is here, it is mentioned the maintenance of physical flow of certain key individual resources, which is incorrect because here we are talking about the talking about the physical as well as natural capital and human capital also. So then the option E is in E will be correct if it is given strong sustainable development rule. Then the substitutability. Uh, then the rule states that there is no substitution between physical and natural capital. So if I ask about the strong substitution, then option E holds correct. Right now we are talking about weak substitution, so option A is correct. Okay, sorry, I've already shown the answer, but economic development is characterized by structural change in economy, change in occupational structure, and then sustainable increase in GNP, and both A and B or none of the above. So the answer I think you have already seen. So the answer is the structural change in economy and the change in occupational structure will be the character of economic development. So with change in the structure of economy, the equitable distribution of income will be happening. So that is one of the economic development. And then the change in the occupational structure of various uh, citizens can be formed as for can be stated as a economic development. So therefore, option D is correct. Next one is when the substitution of natural resources are equal to nature's ability to replenish, then the sustainability is known as. So I first need the answer. Okay. I'm getting D. So everyone is saying that D is correct answer. Uh, okay. Am I getting for the this question right? So when the natural resources are equal to nature's ability to replenish, then the sustainability is. So there is no specific covering of this lecture, but you are saying that the correct answer is D. You are getting for you are answering for these questions, right? So, okay, so here the correct answer is actually steady state economy. So here in steady state economy, we try to find the balance between production growth and population growth. So what we are saying is that the growth of production have to be constant or the growth have to be constant. So what we are saying is that when the economy is steady state, then environment will be balanced. So therefore, in steady state economy, the natural resources, the consumption of natural resources, and the nature's ability to replenish. So we keep certain amount of uh, resource extraction. We avoid certain amount of resource extraction so as to give the nature time to replenish itself. So this is defined as a steady state economy. So environmentally stable is not correct because here what we are saying is that the sustainability is already mentioned here, right? So the economy, what will you call this kind of economy? So steady state economy will be the correct answer. And mm, am I correct? Like, am I clear? So we define steady state economy as the growth of economy, uh, which should be balanced with increase in the population. So the economic growth have to be proportionate. So right now and then next year, the growth have to be proportionate. So that is what the steady state economy is trying to say. So the correct answer will be steady state economy. So is it correct? Vinod, did you get my point? Krishna and Vinod.
Yes,
Am I
yes, ma'am.
clear
Yes,
now? Matlab, I don't know if I'm explaining it properly or not.
yes, ma'am.
It's clear,
Okay,
ma'am.
okay. ठीक है. So that's the correct answer. Okay. And then the last few questions I have. So, okay, EKC is estimate across the section of developing and developed economies. So downward sloping of EKC is for which kind of country? Developing, both developing and developed, or developed, or which kind of country does the downward slope of EKC represents? What is the correct answer? Okay, any more? Pujarini? Okay, so it is straight only, but right now I don't know why I have marked developing, but it is developed only. So I'll change it right now only so that later on you have this stage. So for the downward trends, it is represented by developed country, and for the upward trends, it is represented by the developing country, right? So therefore, we are saying is that there is no overall, there might not be the overall reduction in emission. However, there is a shift in emission from developing to developed country. So that is part of the limitation which we have discussed. So these are few questions which I have prepared, and now we can discuss a bit about few of the basic concepts or anything else which you want to do. Like we have 10 minutes more. So if you want to ask any question, then we can address that. Or if you have any kind of suggestions or any kind of comments, then you can unmute yourself and tell me. And also, I think every one of you know, but you have to submit your assignment on time. So that will be on the portal. So the first week assignment, I think it's already over. The time is already over. So for week 2, you have to submit your assignment on the portal.
Week 2 is also over, ma'am. It's on 7th.
Acha, okay. Week 2 is already over. Okay, that I haven't. Okay, so is there any problem in the week 1 questions, like assignment questions? Anyway, the solution is provided. However, if you want to discuss any of the solutions, then we can do it right now. So, first question is that wasting capacity of E2 is used by. So E2 wasting capacity is used by both consumption and production side, right? So that we have seen from the image which I have shared right now in the start of the lecture. So this is my waste sink capacity, E2. So E2 will be used by both the production and consumption side. So that is one. And then next one is at higher stage of economic growth. In the last lecture, there was one error with this answer, but here what they are trying to say is that when we try to increase the economic growth, then what will be the impact? Who impacts more? So when uh, in the EKC curve, as we have mentioned, that technological component and technological and composition effect will be more than scaling effect at higher level of per capita income. So that is why the option B is correct. So when the economic growth increases, the composition and technological effect will be positive. However, scale effect will be negative, but scale effect is less than these two components. Therefore, the slope is downward. So that's why we get the downward sloping when the economic growth is beyond X star. So the positive impact of composition and technological effect will be higher than negative impact of scale effect. Then EKC curve is inverted U shape, and then from three conditions which we have, you will answer these three questions, and then these are, I think, easy only. So next, here, environmental goods and services are free. Why is it so? Because it gives the improper price signaling to because there is no market, or there is no specific impact which we assess out of the environmental goods and services. So the price signal is improper, because of which there is a more environmental degradation also. So that is the answer. That is one of the reason which we have said that we will try to learn the environmental economics, because the environmental goods and service do not have specific price. So that is what we will. And then now, scale effect, composition effect, and technological effect. So a scale effect have always negative impact. Composition and technological effect will be positive. So when the economy grows, then the cleaner components will be used for the production, and the cleaner technology, more efficient technology will be used. So the on environmental quality, the scale will be negative, and the other two components will be positive. And then the last one is the pollution heaven hypothesis. Dirty technologies are transferred from uh, mm, both B and C. That will be true, because from a developed to developing country, or from higher per capita income to lower per capita income. So pollution heaven hypothesis we have discussed, in which we said that since the developed country have stringent rules, the developing country will be used as a production house. So there the emission will be higher. So the shift of emission from developed to developing country, or higher per capita income country to lower per capita income, is what they are trying to ask in the last questions. And then this is week one, and week two assignment question we can discuss next session in the next session. And right now also, the questions which I have done initially are from week two lectures only. And if you have any more discussions to make, or any more comments, then you are welcome. Or you can mail me if you want to discuss any specific topic in the next session. Then I'll prepare the same also, so that the interaction will be better, and you will be more interested in the class, rather than just listening, or uh, giving the answer which is very obvious kind of thing. So in the next session, if you want to make any kind of discussions, then we can make that also. And that is it from my side. uh, Vinod, do you want to say something?
No, ma'am.
Okay, then I'll end the uh, session right now. So if anyone of you have anything to say or anything to ask, you can raise your hand for one more time. I'll wait.
Thank you, ma'am.
Okay, thank you so much.
Thank you, ma'am.
Okay, thank you. That is it. I'll end the session right now, and the lecture will be uploaded on the portal. So that is it. Thank you so much, guys.
Thank you, madam.
Thank you.